Hello. So far I tried to show you a little about what do you call the use of quick prototyping. Instead of using the word 3D printing and this thing, I have tried to, for example, in yesterday's lecture I already showed you a little about how to make a cardboard model, how to make things like this. Traditionally all machining, all manufacturing, everybody used to do it on their own, only it is not fully formalized. But since around 30 years or maybe 40 years since the advent of computer aided design and graphics on a personal desktop has come to be, things have changed a little. So, one of probably the earliest one, Autodesk's AutoCAD release I think 2.6 or something, must have been very old. Later on it has got stabilized as release 8, release 12, release 14, 16 and so on, which in principle concentrated on simple drafting. Means you already have something and do it, but then things have been changing parallelly, saying the moment you can modify something without losing anything, and it is only you can keep several types of files. Whole concept of saying why can't we use it on simple geometric design has come about. Later on huge field has come out saying, oh, you have so many of them which is related to this computer aided design, then computer aided manufacture, then whole thing called PLM life cycle. So, just let it be there. The idea being that you need to use some form of a computer aided design for you such that you can make use of the facilities that are available. So, in the case of sheet metal, if you go to SolidWorks, there is a sheet metal extension that is available. With that, things like bending elements, all those things are very much possible. So, I draw your attention to this large number of, you have a look at this monitor. So, if you go here, my own lectures are there, large number of them there on the this thing here as part of the NPTEL channel, as part of another lecture series called this what do you call product design and things related to this. Parts of what are useful in this current course are also covered there. So, if you see here, I'll show you this a little. It is a short lecture, though it says 25 minutes. I will just skip through quickly and then see. You have seen this. Most important is saying anybody can make use of computer aided design, and once you start in this CAD very well, you can always go on to the next steps. See, this is where the important thing comes, saying downstream what are, as nebulous concepts in the mind can be made into usable data, and the over the wall design you can always avoid completely. And down the steps we have this prototyping. So, prototyping itself, I have already given an example of how well things can be. So, we can have accurate representation of features, sizes, scaling, both in the terms of quantities. You can make multiple copies of the same, and scaling of individual entities. You can make them bigger or smaller. If once you make a metric proportioned fastener, probably you can just making it is easy. Then duplicating, if you make one object sometime in your life, you can keep using it and build a library. And the magic is online, lot of these open source are available, and you can make things more and more complex. So, this stuff I suggest to go out and see lectures which are part of the other things. This one, this particular thing is from a series called the what do you call have just so let me start with this particular thing, which is in a way a continuation of where I left off yesterday. This one was part of a electronics, very complicated power electronics project. In this year, to me it is a little threatening, but then nothing for you to worry about. All this stuff now needs to be packaged. You have seen that, not easy, no? So, we have taken one commercial device and try to understand it as much as we can. There is a cover, and then you see this detailing of how these things, in fact, if you see, it looks a little like a automobile gearbox. Whenever you see these automobile devices, no, this detailing has come from there, saying we have a counter bore, and because it is nearer the edge, all the proportions and all have been maintained. This is where I would like to stress. So, if you want to make a duplicate of this, just like that, or now going to the machine shop and trying to make these things will invariably end up with surprises, which we need to prevent. So, what we have done is, we have tried to take a, this is not a copy or anything, we happen to have this drive and probably sponsored by the company. Now, if you see here, including the way these things are strengthened, and you see various types of location items, all this you can learn, observe from it. Well, I won't call it copying, and neither is it reverse engineering, neither reverse innovation or anything. For a first timer, it makes a lot of sense if you make this. These probably are meant for locating, so that it sits properly, and this is for ribs are for strengthening and reducing the weight, and then these are the critical things which you need to observe from a equivalent similar thing. It is a little related like search for publications. You have a patent search, and then you have a search for published data. So, moment you see all this stuff, you will be able to take a few details that are required from it, and you see here we are slowly coming to the crux of the thing. We went about trying to see if a similar top belongs to the other cover, and then whether we can make a similar enclosure, but vastly simplified. If you see the original drive, it had a lot of extra pieces, and probably one of the rare pictures at the left, if you see, is a IGBT module which blew its top. You seen here, it is an IGBT module which has blown its top. So, we have all the stuff inside, then we have the terminations, we have everything and all this. So, a good way to learn, maybe safe, maybe unsafe, a good way to learn is that now you notice this is very crude. The it's a sand casting, simple sand molded lone casting, we try to use it. This is where I thought I will tell you that maybe if you had made a small scale model using any of the techniques, and specifically rapid prototyping, obviously we would have saved a lot of time. So, I will stop here, I will just quit this. I think enough of it. Now, small portion inside this is this water cooled cold plate. So, on the top surface we mount the what you call the power devices, and the bottom surface is part of the casting, so that we can make the maximum use of it. And what you see here is channels have been made for the cooling of it. Now, is it important here? Yes, of course it is important here, saying we could have avoided several pitfalls which we managed to do. You see here, you can see some very interesting thing here. This is made by our student was working on it. You see here, this is a first level, I will say, adaptation of a standard industry practice. So, what has been done is they try to make small channels, they are not full fledged micro channels, but however this whole thing is an extrusion that comes directly off a machine, and then they try to machine all the parts. After fabricating everything, we have discovered that we could have avoided some of the things here. Now, if you see this corner, this is where now do you see something here in this corner? The interesting thing are they are not tapered fins, because while tapered fins gives you optimum fin effectiveness, fabrication is a problem. You need to have a special cutter and making it. Instead, we have used two what you call slitting saws, and then afterwards first made a groove, a 3 millimeter groove, after that made a 1.6 millimeter groove, and hence we get this what is equivalent a little to the best thing what we can achieve. So, I will see if I can have a what you call some graphic yeah. I will use an empty slide and see whether I can write a few things on this. See, original heat sink involved having to make fins like this. I had explained somewhere else saying why fins should not be thin and long. This type of fins where you have a long deep fin and adjacent very small gap, and if you keep making things like this, these are useful in the case of natural flow or where the velocities are small, because there is enough flux available and enough time for the fin to reach the same temperature throughout the thing. But if you start cooling it, imagine we have air coming out from here in all the directions from one to the other direction, you will find that this tip cools fast and this temperature remains as it is, and the moment it comes to here, we find the tip may be just about plus 5 degrees above ambient, and this may be 50 degrees above ambient. So, this last portion of it is practically not at all useful. So, very rarely people use such things in the case of fluid cooling. Instead, what is used is a tapered fin with sufficient spacing. spacing is to provide for compensation of pressure loss and improve the flow. So, we have enough fluid which is passing there, and from here now the heat flux, let us say this is the base plate, heat flux comes here, this whole thing is taken by this section and slowly heat starts flowing here, and if the base is typically, let us say at 80 degrees centigrade, the tip, the loss to the tip may be only about 70 degrees centigrade instead of 30 or 40 degrees. Now, if you are to make the same thing and try it on a what you call commercial heat sink, life is going to be not easy. So, at this point only those critical elements which need the actual what you call physical simulation, we can make it like this, else we just need not worry too much about it. See here, this part of it is the heat sink, and then some channels have been made here, and you see this is I mean thicker and it blocks here, and the I think one of these drawings, water is supposed to enter here, and this forms a header, input header, inlet header, same header as you will find in a solar what do you call passive solar water heater. There you will find a series of pipes. Instead of that pipes have been created, many channels have been created by butting that heat sink fins across this. So, you will have, this is the header and all the fluid will pass through. It can be in the normal course, it can be simple water like as in distilled water. Alternatively, it will be same distilled water which is mixed with your refrigerator coolant, your automobile what do you call water coolant. Coolant is a mixture. You probably have propylene glycol and anti-foaming agents and all that. So, it has certain advantages of maintaining viscosity as well as maintaining conductivity and across all temperatures, right from very low to very high temperature. So, if you use one of those car engine coolant liquid here, it flows like this. Afterwards, since there is a positive pressure, this acts like the next header from here. This part of it is this inlet header, this outlet header. Next this will become the inlet header 2 and this will become the outlet header. And this outlet header again becomes inlet header 3 and then it becomes the outlet header, and we can go. And if you are to make this properly in a proper what do you call software, you will notice that you can easily carry on simulation work. If you carry on simulation work, we can estimate the using what I call various types of software, possible for us to estimate the heat loss or the heat gained. So, since we already do not have the heat transfer conductivity for this flow, we need to, if we have a perfect model, we can within a very good accuracy, within a few temperature maybe 5 degrees centigrade, assuming various parameters including conductivity, including the heat transfer coefficient in convection for this fluid, very much possible for us to estimate this. Once you estimate it, you can optimize the physical layout of it. Right now, the physical layout is almost optimized by 3 IGBT switches we have here. We have 3 switches here, and this is just a little more than the switches. Remaining this much of mass is required for various other parameters. And next is the airflow can easily be modeled. Why I am saying it is, if you are to build the whole thing in a 3D printing, we would have had something to see, we could have opened it, we could have found out where to split it, we learn by our mistakes. So, now if you remember, did you see that casting which I showed you earlier? This is the model of the casting. We have placed here for electronics, we have placed here for the electronics. This is the cold plate on which devices will come. Specifically, this is probably used to keep DC link capacitors and all that. No, this whole thing is very much possible for us to make it. This is the bottom portion, and you see here all this stuff now is sitting here. The original model, because of traditional way of manufacturing drives, it had water cooling from here. So, we had a water channel which runs all the way here, and inside and lot of other things are there. In our case, our interest is only to cool this and also estimate the temperature rise and the maximum we can go with. See, as things are placed, things are getting very interesting here. Can you see here now all the other details, including the way these micro mini channels will work, including a water inlet here and a water outlet, whole thing has been made here, which I feel is part of the what you call new wave electronics design. Now, if you see, we cannot isolate it saying this is only meant for to be handled by one person or the other. Advantage of following our this new system is same model can be used by the mechanical or people who are working on the heat transfer to model it, including materials and all that. Same thing about how much of area is available and how to make a physical layout of the unit can be made use of by the layout people. And because in the case of these we are switching large current 1000 amperes and we are switching at a little higher frequencies. Now again suddenly as the frequencies kept going up in small thing, it was welcome. Now it looks like everything is coming but down to something which will give us a cleaner power supply. And so the same model can be used for physically modeling the fluid dynamics part of it, and the same thing can be used in the manufacturing process. This is only for reference to see typically how much these things are. Probably I have come to the end of this. Now, this is taken from our machine shop. So, well, it looked neat and clean there. In reality, there are chips everywhere. So, and then lot of other further processes are there. Right now, because of our what do you call, you see here now, this is what I was trying to tell you. This is still partly in the process. First, this opening has been made with a larger slitting saw. After that, a smaller slitting saw is open. So, in principle, except for the little bit of these accumulated errors, you need to ignore these accumulated errors. But in general, if you see, it follows what we were looking for, saying I need to have a thick base and then a little thinner profile. Now, this face will meet the other face on the other side, and then you see what this is here. This intentionally has been made as a separate piece, saying those channels, do they really behave the way we want with an S-shaped thing going on like this, or if we remove it, maybe we have one what you call input header and one output header, and the flow will be better and about the same heat transfer coefficient we can get. So, this has been attached here. So, if you do not want it to avoid this thing, eventually for ease of fabrication, maybe you can just remove all these things and make things a little more easier for us. Can you see here things slowly they seem to be coming here. This is the other part. Now, this part this part will go and sit in the other one. So, the small ridges you see there will all sit in these grooves. We have a groove, understand, this is the outside, then we have 1, 2. So, the fluid is supposed to come here and it go around and all that. Eventually, if we find that there is not much of heat gained, maybe all we need to do is open it and remove these small flow diverters, and all the water will the what you call liquid coolant will come and coolant will go away, and the probably total pressure loss will be less and flow will be better. And our electronics engineer Professor Rumanand has suggested, if we make all the openings and all little large, is it possible for us to make simple thermosiphon, saying if you just need to tilt it a little, maybe say keep it at 60 degrees or so. So, maybe the fluid will all come here, go that side, and we can avoid one unreliable pump. If we avoid the unreliable pump, we have something which is passive. So, while this is made for a drive for a I expect an electric motor, similar drives can be used even for power transmission and all that, and we try to make them as passive as possible by preventing components like fans. So, while this part of it we try to make it flow easily, correspondingly we have this part of it loosely, let me call it a evaporator, then we have a condenser. Alternatively, this is the hot what do you call heat exchanger, then we have a heat exchanger to the ambient. Both of them, even there is a fan. If you now invert it or keep it horizontal, we can have a whole system which works only in natural thermosiphon. So, we have been trying to see if we can eventually make all these things here. Can you see this again? This is something which we managed to get from the workshop. I thought I should show you these things. I am a little thrilled. Yeah, I think this is all. Then, yeah, these are this has been provided from the SolidWorks file. Seen that, no? This is the one which I have shown you separately. So, unfortunately, these things how to tell, let me show you his. See here, this is where the water opening comes, and you see here this is taken from an earlier concept where we wanted to machine this whole thing like this. Then we have found out it is a wasteful and unnecessary thing. The corresponding thing what we need to make in the heat sink, we have to make all this funny stuff. Instead, it has been just machined through using probably a 6 mm or an 8 mm end mill. The whole thing has been machined through. Same end mill is run here, and to make multiple parts, the same file which is used now, the G code file can be used here, so that the whole thing can be machined directly using a CNC machine. And you see here, interesting thing is we have a fluid inlet. So, we have a fluid inlet here, fluid inlet, and how the whole thing comes out. So, very happy to see that these things work easily, and magic thing is we have all this. So, we have all these things have been done, but right now these things do not open in this what they call the monitor software. So, any of you are interested, I suggest you try it. If you try it, these things come in SolidWorks assembly, SolidWorks what they call part drawings, and then we have other solid what they call files which can be used in 3 places. I told you, once you make the solid model, you can use it to convert it into a way for fabricating the items, and the same file can also be used in 3D printing. Why 3D printing? Why all this is to make it at a full scale, because as of now buying a special type of aluminum, which is aluminum, silicon, magnesium, machinable, what you call coldly packed extrusion is still expensive, and you cannot get it in small quantities. If I just want a what you call 200 mm by 150 mm piece, and which is probably 50 mm thick or 225 mm thick pieces, difficult. Searching, ordering itself makes a problem. But instead the same thing, say to half scale, it is easily printed using our usual 3D printing machine. The moment you have it in a 3D printing machine, now you can take them, close them, and then put yourself for a discussion, and the same unit can be used by all the people involved. I am from the mechanical and fabrication and what you call integration person. So, while I have shown you a small part about how to fabricate it and how to print it, now if you take that big box, big enclosure, it has so many other things. It is built for electronics, and it's, if you recollect in the earlier what they call the video file, you would have seen large number of, very large number of electronics parts everywhere. It's full of wires, it is full of I do not know, connectors and everything. Unlike low power electronics, everything, the minimum voltage is 400 volt RMS. So, something like 600 volt RMS, 600 volt peak voltage is present everywhere. Risky business. So, that whole thing, if you have to simulate in a scale model and keep it, it will be useful everywhere. I expect this is what people have been doing all along. So, let me see. So, we have here so many of these things. So, go to your NPTEL wherever it is, these are all public what you call in the public domain. So, you will notice while my part is this, which I thought no, I need to stress, so I had kept this towards the end. In reality, I kept it towards the end so that you will appreciate. Please have a look at this lecture. A lot of it depends on so called now industrial design. So, well, design we know very well, it is part art and part this thing. In the case of this, here design is meant for producing in an industry, and unlike conventional simple design, whether you like it or not, all our things involve having an aesthetic appeal. Products look good. Even if you are to buy a, I do not know, mobile phone, or if you are to buy an audio apparatus, or if you are to buy a TV or a monitor, or best is, biggest black box is the system unit or the CPU unit of your computer, but still lot of aesthetics are built into it. It looks like people want it whether you like it or not. Then how easy to use these ergonomics, then the functionality, how functional they are, and finally marketability. In the case of marketability, it is not about selling, but it is about creating a position in the user's mind, saying I need it, I am going to get it. So, design involves all these things, and probably these our this physical prototyping techniques help us towards this. So, my suggestion is kindly go to this other what do you call thing which I have recorded, and you will be able to see things. Not long ago, there was this thing about pigeonholing, saying I am a electrical engineer, and then he is a mechanical engineer, or he is a production engineer, he is not a machine design person. So, all activities, everything have been pigeonholed. Right now, at least in the case of enclosure design or any products design, we end up with this pigeonholing will not help. You see here we have 9 holes, but there are 10 pigeons. So, probably that is mine, is it not? I am the 10th pigeon. 2 pigeons are stuck in that. I am supposed to do the fabrication part, I am supposed to do all the non-electrical part, and the electrical itself has been spread. So, there is an EMI expert, then there is a expert who works in what you call low power electronics. Earlier anything less than a watt was called low power, right now no, everything has become ultra low power. So, people are talking about milliwatts total. When energy harvesting comes milliwatts. Similarly, other extreme we have very high voltage high power people, and interconnection people are separate, and devices, circuits and all that. Now, this does not hold good anymore. Some of you who have been out may have discovered what is this what you call alien attack. I think you know it, I will leave it listening. It is not an alien, neither they are what you call something which is walking and trying to attack you, but then it does keep you happy. Seen that, now we know that no, all design is emotional design. It sort of flashed and went off. Let me take it back and say whether my aliens are still there. See, aliens are attacking us. Actually, the issue is about we love or hate everyday things. So, it is for you to make things, and even things like this very complicated thing can easily be simulated, made in a computer and printed. Now, again coming back to the printing option, the whole thing can probably printed in one go, but uneconomical. Instead, it would have been easy if you make one let us say these 3 legs separately, and we have this I do not know the actual citrus squeezer, and print it, and then eventually attach it together. We have a very nice product. So, allow me to just I myself, I seem to be loving my voice. This should be the end. After that no, I will stop. Not long ago, while that was the over the world design, here we have a beehive. You have seen that, no? I am not going into the philosophy or what you call unfairness of nature, that there are so many more workers for other than a queen. Thing is, all of them do all the work. Seen that, no? It is a beehive of activity, but together the output is stolen by humans, which is sad. But the bees are required. Without the bees, we do not seem to be able to survive, is it not? Eliminating all the bees does not. So, you can go to the YouTube channel and look up all these things. One small part of it is my what I have covered, and this last part was about what I call 20-hour session about how to make small products and so on. And you need to build all the things, including all the small type of connectors, wires, then I do not know, displays, clamps, everything. You need to have a repository of all these things available, and for making a physical prototype, well, they are very useful. When you want to actually manufacture it and make an enclosure, if you have it with you, you can always take a measurement. So, if you have this, I can take a measurement, take a vernier, find out diameter in each thing, and then inside here, no, if I open it, there is a switch somewhere, and there is something here. I do not know what exactly it is. Probably it is a something which prevents scratching here, anti-scratch something. I can't see anything. And then there is something which is detected as a eraser. While if I do here, it does filling. If I do this, entities are erased. Not easy, no? Somebody has made it. The beauty is this can easily be made by you. If you go around searching on the thing, this is only an introduction, what you call a thing so far I have given. So, I can say best of luck for you, and 2 or 3 things is, In the initial stage, probably you need to get something like this, take and observe it. When you open it, see how well they have integrated everything. You see here, we have a box in which they have put so many things together. I am sure if you are a normal person, you would have had so many failed spoiled devices like this. So, inside you know how this scroll wheel works and how these buttons work and how the whole thing is there, and then little bit of what I call ergonomics, what I was telling you know, there is a place you can hold it to squeeze, and you see in the four corners no very critical things they have given here, saying there is a small foot which slides easily. The same thing in another what I call instance, it will be something which will should not slide even with its natural weight, given so many grams it should not move. In this case, even if you have to lean on it and push, it moves smoothly. So, this part of it is a functional thing, we think it is a very minor matter of detail. So, if you work out all these things and including all this enclosure, this whole thing now probably making another mouse is easy. And going back to the adage by marketing people, if you build a better mousetrap, the world will beat a path to your door. Fortunately, mouse are stronger, they live. Mice are stronger, and same thing with chairs, apparel, anything you wear, the ultimate has not yet happened. I have a funny chair here, maybe you can have a look at it. Every time we buy a new chair, we will find that is in some other way, no, it is a compromise. Compared to that old fixed wooden chair, seem to make sense for old people like us, meaning I can grip, I can put force and get up. If I try to do with one of these easy moving things, the chair will move away, and it look like one of McLaurin's movies, saying a cherry tale, saying how a man they what I call tries to sit on the chair, how it keeps moving away. Now for me, unless I keep doing it, this chair is not the ultimate design. So obviously somebody will improve the design. And for each of these things, the easiest way is for you to make a physical prototype. To make a physical prototype, not long ago, about 20 years back, was tough. You had to depend on carpenters, you have to depend on pipe benders, you have to depend on workshops and all that. Now right now, you can easily create a 3D model, and once a 3D model is available, it's a small scale things you can print. So it's limitless. If you are to make a new table fan, we are all familiar with normal pedestal fans, you are familiar with table fans, now you are familiar with regular ceiling fans, and there are so many more, and some of you would have seen the small USB fan, and then the one and only so called bladeless hidden blade Dyson fan. So if you go and check for the what you call Dyson lookalike or clones, you will be tempted to make it. One critical part about the Dyson fan is the way they are flown. So we have a annular ring, and which has a peculiar profile, air is blown through it. Now that those profiles and all that, it is very easy, like what I showed you yesterday. You have to make a proper airflow profile in any of your what you call using any of your surface modeling software. Next you have an axis of revolution, the whole device is ready and the whole device can be printed. So if you want to make a bladeless fan in which blades are mounted at the base, and then you made the annular ring and then make the thing flow, you can start, and you can have a bladeless fan which is probably USB driven. So I will stop here. Thank you for patiently what you call listening to all this. And 2 or 3 things is, I would like to acknowledge the various sources which I have taken, some of them which are already there on the what you call, as I have started searching on the internet right in front of you, it is semi public information and I have acknowledged it fully, I full support it. And the occasional software which I have used, they are all trial software or licensed for our institution. But in your case, I suggest you buy one. Even the what you call simplest solid any software, individual for what you call simple hacking purposes. Hacking means not for cracking the software. For you to use it doesn't cost too much. Maybe good one you should get for about very good commercial works for everything maybe $500. Very simple thing around $200. You can pay and get it. Alternatively, you can share with your friends. But it's unlikely that anybody will be making use of them alone. You will be part of some entity. So buy the full-fledged software and then use it wisely. And if you acknowledge all the sources, you can always file a IP for whatever product you can think of. We are all familiar with this, eyeglasses, monocle. Something here, if you are one of these what you call old time things, you have a monocle, they have a chain, and somebody takes and does it, and then you have a latest, I will call it binocular without this side things, it sits on the nose. Those things you can now make. If you want to make a what you call that over the nose reading glasses, it's very easy to print, and in fact you can probably go and buy, because this is expensive, this is a regularly progressive coated photochromic and so on. It is a trifocal progressive glass. So I won't try it on that, but however you can go to your what you call optometrist or optist and buy. You have 50 glasses, you have also 40, and then if you search around you get probably 32 glasses are available. Take two 30 round glasses and then make a frame which sits neatly on your nose, and you can probably mold this. You can mold, or better still, go to a surgeon and have two notches built into your nose. You can always make it sit there, so it won't fall off, and in my case it won't interfere with my hearing aid. So best of luck. Thank you. I will sign off here.